So this learning target is going to cover what happens when we have two vectors that are combining and the angle between them is not a 90-degree angle. So first off, a sketch of what's going on here. In part A, we've got one vector that is obviously a little bit bigger than the other vector. So right here, let's call this 6,800 newtons of force. And then the other vector hits it at a 30-degree angle. It's just a little bit shorter, 5,700 newtons of force. Well, parallelogram, I need another 5,700 over here. And I need another 6,800 here. And the reason that's important is the resulting force is going to be the diagonal across the parallelogram. And because we've got 30 degrees used up here, and the opposite angle for this to be a parallelogram has to be 30 degrees, the consecutive angles, so this angle of 30 degrees has to be supplementary. So 180 minus 30 gives me 150 as those angles. So why does Pythagorean theorem does not work? We don't have a 90-degree angle. This is not a rectangle or a square where we have right angles. I can't use Pythagorean theorem to get the combined magnitude of the forces. So now part C, we're using law of cosines. To again find that diagonal, I can pick whatever letter I want. I'm going to go D for diagonal. So D squared equals, all right, what are my two side lengths? 6,800 and 5,700. So the start of law of cosines is this squared plus this squared, the two sides that are adjacent to that 150-degree angle, minus those two sides again, and then the cosine of the angle where those adjacent sides come together. So there's our 6,800 again. There's our 5,700. And now if I'm super sweet, I understand my variables just left over here. I got to cancel out a square. The way you cancel a square is square rooting all of that. All that is some sort of number. So it's just don't type it in wrong. Get it in there in the calculator correctly. 6,800 squared, 5,700 squared, minus 2 times the 6,800 again. The adjacent sides are dropping in. The 5,700. And now the angle that they're adjacent to, and the angle that's opposite the diagonal on the parallelogram, we get that the diagonal, the distance, the combined magnitude going across there is about 12,077.4 newtons. Okay, and now for part D. Part D, what is the combined angle, the direction of the combined poles? So I'm going to find this angle here. That's what it's asking for. Really, I'll find both angles, and I'll explain that here at the end. So now we got that 12,077.4. We can quickly set up law of sines. So I don't know an angle. Let's call it A. But I know that opposite this angle here is the 5,700. And that has to equal the only other pair of side and angle I have, the sine of 150 goes with that 12,077.4 that we just found. So I can crunch that. I can break this up into steps. I can also do a whole bunch at once. It's just how comfortable you are with things. So I get a really, really small number temporarily. Okay. Anytime you get E's on your calculator, that's telling you move the decimal over 5 times. So this is actually like 0.00004-ish. The way you cancel out division is multiplying. I want to fit that in a little bit neater. Just need a little bit more space, running a little bit short here. And the way you cancel out sine is sine -1. So that gets that point, that 0.004, again, it shows up on my calculators, 4.1399 something something e -5. Tells me it's a really small decimal. And if I multiply that by 5,700, I get 0.23-ish. If I sine that, sine -1 that, we get about 13.64 degrees. So now if I go 180 minus the 150 used up, minus that 13.64 degrees, I will have all the angles in the 16.35 degrees. So the right here in the triangle, 16.35 degrees. And right here, this is the angle that it would actually pull that in relationship to the larger force, is 13.64. And I did round wrong. That should be 13.65. You should notice 13.65 and 16.35 adds back up to the 30 degrees. That's at each of those corners. So you should be able to find both the angle from the stronger force. That angle should always be smaller, 13.65, and the angle from the bigger force, it's alternate interior angles, 16.35 would be here, 13.64 would be there, 13.65, excuse me. Hope this helps. Again, some law of sines and law of cosines, because we can't use Pythagorean theorem because we don't have a right angle.